Welcome to our chemistry class. See, students, we are studying chemical bonding and molecular structure chapter. In this chapter, so far, we have been discussing so many topics: ionic bond, covalent bond, types of covalent bond, the same way bonding models, all those things we are discussing. Today, I would like to explain the other types of bond. Actually, in our intermediate standard, bondings are of five types. What are those? One is ionic bond, the second one is covalent bond, third one is coordinate covalent bond, fourth one is metallic bond, fifth one is hydrogen bond. So we have five types of bondings. In that, so far we have studied first type, that is ionic bond, then second one covalent bond. Today I want to teach third one, that is coordinate covalent bond. Coordinate covalent bond. Coordinate covalent bond. See, student, it is also important bond, and it will come in higher classes, particularly BS final year. So, first of all, what do you mean by coordinate covalent bond? How it is formed? All those things we discuss now. See, actually, coordinate covalent bond is a special type of covalent bond. It was discovered by scientist Parkins. Later, it was developed by scientist Sidgwick. Actually, the bond which is formed in between two molecules, this bond is formed. In this, one molecule can act as electron pair donor and other can act as electron pair receiver. So, in between donor molecule and acceptor molecule, there is a formation of special type of covalent bond that we consider as coordinate covalent bond. Actually, it is represented with arrow mark, arrow mark, and that head is pointed towards acceptor atom of the molecule. In our syllabus, we will be having a beautiful example. What is that? Ammonia and boron trifluoride. You know, ammonia is an electron rich molecule. Nitrogen contains lone pair of electron on it. Boron trifluoride is a electron poorer molecule, electron deficient molecule. Moreover, third A group elements all are called electron deficient elements. That's why their compounds are also electron poor and electron deficient molecules. So boron trifluoride, in center atom boron, it has one empty p orbital. So in between these ammonia and boron trifluoride, ammonia can donate pair of electron pair to empty orbital of boron in boron trifluoride molecule. So there is a bonding. That bonding we consider as, what is that? Coordinate covalent bond. See, I show you, for example, ammonia. Okay, it has electron pair, lone pair of electron, boron trifluoride BF3. It has one empty p orbital. In between these two, what happens? Nitrogen can donate electron pair to the boron trifluoride. By this, what happens? Here, bond should be formed like this. Here, ammonia donate electron pair to the boron trifluoride. Okay, this arrow is nothing but, this bond is nothing but coordinate covalent bond. Coordinate covalent bond. Okay, represented with arrow mark, this point, this head projected towards receiver, electron pair receiver. Okay, so this is called what? Coordinate covalent bond. It's a very simple phenomena. But here is the case, what you try to remember, which molecules are electron donor molecules, and which molecules can act as electron acceptors, that you want to know. Then very easy to follow this coordinate covalent bond. So see here, one more thing, as per Lewis acid base concept, whatever the molecule, donor molecule, can act as Lewis base. This is Lewis base. So that means donor molecules all are acting as Lewis bases, and molecules which can accept the electron pair all are can act as Lewis acids. In our example, ammonia is a Lewis base, boron trifluoride is a Lewis acid, so is a electron pair receiver. It is electron pair donor. Through during this, what happens? The resulting bond we consider as coordinate covalent bond. Okay, so particularly as a student, you want to know in you want to know which molecules can act as electron pair donors, which molecule can act as electron receivers, electron acceptors. Particularly, I think all you have studied block elements, group elements. Particularly, fifth A group, sixth A group, seventh A group elements and their compounds, they have empty lone pairs. That's why those are nothing but electron rich molecules. They act as, what is that? Electron pair donors act as Lewis bases. What are those? For example, see ammonia. Ammonia having lone pair, that's why it is a electron pair donor and also Lewis base. Like that water molecule, like that HF molecule, seventh A group. So ammonia derivatives, most of the ammonia derivatives are Lewis bases. They able to donate electron pair. What are ammonia derivatives? Primary amines, secondary amines, all those things you have seen in our organic chemistry also. Okay, when come to Lewis acids and electron pair acceptors, what molecules can act as Lewis acids and accept electron pair means particularly third A group elements, boron aluminum family. That is that family itself, it is electron deficient family. Then second A group metal compounds, first A group metal compounds. So that means 1, 2, 3 group elements and their compounds, they can act as acceptors. They act as Lewis acids. Right side of the table, fifth, sixth, seventh, they act as what? Lewis bases and electron pair donors. Okay, this is the very important thing here. See, you write down simple points. You have to write down. I give you notes also. I can upload PDF notes in our app. You go through it. Even though you can write some bullet points to understand clearly. Write down the special type of covalent bond. Special type of covalent bond is formed is formed in between in between electron pair electron pair donor molecules, electron pair donor molecules, and electron pair acceptor molecules, acceptor molecules acceptor molecule. That means one atom of a molecule, one atom of a electron rich molecule, one atom of a electron rich molecule. Best example, ammonia donates pair of electron pair of electrons to the atom of a electron deficient molecule. Atom of a electron deficient molecule. Deficient molecule. What is that BF3? You know BF3, electron deficient molecule. During this, during this special bonding, special bonding is formed. This is called coordinate covalent bond. This is called what we call coordinate covalent bond. Coordinate covalent bond. It is shown with arrow mark. It is shown with arrow mark. Arrow mark means like this. Arrow mark. Head is pointed towards. Head is pointed towards. Head is pointed towards. Head is pointed towards electron. Electron receiver atom. Okay, this bond was identified by scientists, identified by scientists identified by scientist Parkins, comma Sidgwick. 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 Scientist Parkins, Sidgwick identified this bonding. So I write here example. See example, better example. Ammonia. Just now I said it is having lone pair. Boron trifluoride having empty p orbital in it. So here what happens? It donates pair to the boron trifluoride. So that here there is a formation of bond, special type of bond. This is called what? Coordinate covalent bond. Coordinate covalent bond. This is called coordinate covalent bond. Coordinate covalent. So, as per Lewis concept, the paired molecule act as Lewis base, and all Lewis bases also called as ligands. Ligands means molecule can donate, molecules or ions having capability to donate electron pair to the other molecules. Nothing but ligands. So Lewis bases and ligands both are same. This is a acceptor, so this is called what? Lewis acid. Lewis acid. So here the important note I give you, what is that? Particularly in periodic table, fifth A, comma sixth A, seventh A group, compounds act as electron pair donors, and also act as Lewis bases. Lewis bases in the sense, you remember new word, that is ligand or ligand. So whatever the donor molecules, electron pair donor molecules act as Lewis bases, and also that donor molecules newly called as ligands. This term you will be hearing in the chapter what is that coordination chemistry or metal complexes. Okay. See, I give you examples, donor molecules examples. So write down what are donor molecule. Regarding fifth A group ammonia, ammonia and ammonia compounds, ammonia derivatives, hydroxylamine, okay, like that hydrazine and amines, primary amine like that, secondary amines and water molecules, H2O, like that alcohol molecules and HF, etc. Oh, these are enough. This much of information is so enough. Okay. Then you write what are what molecules are poorer molecules, deficient molecules. That means generally, generally first A, second A, third A, group compounds, group compounds act as act as electron pair acceptors, 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 because they have MTF, because they have they have low electron density, low electron density or empty empty orbitals, empty orbitals in them. These are also called, these are also Lewis acids. Lewis acids. I give you best example. Boron trifluoride is a electron acceptor, like that diborane, like that AlCl3, like that RMGX Grignard reagent, okay, etc. etc. So I give you some extra matter also for the purpose of entrances like NEET and IIT. See, formation of formation of tetraamine tetraamine copper 2 ion complex is a better example to understand coordinated coordinate covalent bond. Formation of tetraamine copper 2 ion have complex has coordinate covalent bonds, has coordinate covalent bonds. See, I show here. So here what happens, see, Cu plus 2 reacts with 4 ammonia gives rise to CuNH3 taken 4 times plus 2 complex. This is a beautiful example to understand coordinate covalent bond. Here copper D block metal which can have convenient vacant orbitals in them. So here ammonia electron rich molecules, each ammonia, in ammonia molecule nitrogen is having lone pair electron pair on it. This electron pair donated to copper, donated to copper. So these bonds we consider as what? Coordinate covalent bonds. Those are nothing but coordinate covalent bonds. These ammonias can act as ligands. Ligands in the sense Lewis bases also. Okay. This much of information is enough to understand the coordinate covalent bond. It is too high. Okay. This is nothing but what is that? Third bonding in covalent bonding, third type of bonding, that is coordinate covalent bond. Okay. After completing this, we have another one, fourth type of bond, that is metallic bond. I tell you just now. I want to explain metallic bond. See students, just you can copy down running notes because it help you very lot to understand, and it that means so that you remember long time. Okay, I remove this. Then next type of bonding, fourth type of bonding, that is metallic bond. It is very simple one, metallic bond. metallic bonding or metallic bond. See, what is metallic bond? Actually, the force of attraction, the force of attraction, which can hold the metal atoms in the metallic cluster, in the metallic lattice, or in the metallic crystal, whatever it may be. So the special force which can hold the metal atoms in the metal cluster, that force of attractions we consider as metallic bond. You know, by nature, metals are electropositive. By nature, metals are electropositive and having low ionization energy, so that they easily loses valence electrons. Due to the losing of electrons, metal ions converted into metal ions, nothing but cations. Those cations, what we call, as per electron pool theory, electron C theory or electron pool theory, the resulted cations in the metallic cluster called kernels. Those are called kernels. And the emitted electrons in the metallic crystal or metallic cluster, those emitted electrons are called, simply those are called mobile electrons. They move freely from one place to other within the crystal. That means each and every metallic crystal or metallic cluster, whatever it may be, or metal lattice, having free mobilized electrons from one end to the other end, from one place to other place, in a disorder manner, so that metals can conduct electricity. They are the good conductors of heat and electricity, everyone knows. Okay, so here our topic is, what is that metallic bond. In metal cluster, what happens, there is a cations, nothing but kernels, and emitted electrons, nothing but mobile electrons. In between cations and electrons, mobile electrons, there will be a development of, there will be a development of force of attraction. That force of attraction we consider as metallic bond. That means electron which is binded with kernel due to the attraction forces, such forces we call as metallic bond. So the metallic strength increases when mobile electrons increases. When mobile electrons increase. So oftenly everyone knows, among 118 elements in the periodic table, most of the elements are metals. Most of the S block metals, first year, second year, alkali and alkaline earth metals. In the same way, D block almost all transition metals. So S block metals, D block metals. Regarding P block, a few can act as metals. That means around 90, up to 90 elements, they can act as metals. They are metals. Okay. So you write down. It's a very simple. Write down the force of attraction. The force of attractions. The force of attractions, which can which can hold hold metal atoms, which can hold metal atoms which can hold metal atoms in metallic cluster, in metallic cluster in metallic cluster is called, that force of attraction we consider as, is called metallic bond, is called metallic bond, is called metallic bond. A simple one. Okay, see students, you write down some important points. As you know, generally metals are metals are electropositive 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 elements electropositive elements in nature, and having low ip value, and having low ip values low ip values. Metals lose electrons, particularly valence electrons. You remember, particularly valence. Those valence electrons change to change to metal cations, metal metal ions, metal ions. These are also called, cations. Metal ions are nothing but cations. Okay, two metal ions, which are which are called which are called kernels, which are called kernels as per electron pool theory, as per electron C, or it is also called pool theory. Okay, as per this theory, emitted electrons emitted electrons move freely in metallic cluster, metallic cluster. These are called mobile these are called mobile electrons. These are called mobile electrons. Okay. Here the case, here there is a there is a there is a force of force of attractions attractions binded up with binded up with kernels kernels and mobile electrons which is called metallic bonds, which are called which are called metallic bonds. This is notes about metallic bonds, students. So I give you the resulted cation. It is kernel. These are kernels. So these kernels are binded with electrons, mobile electron. Minus means mobile electron. These are kernel. Kernel. This is mobile electron. This is mobile electron. So whatever the force developing in between them, this is called metallic bond. Metallic bond. Okay. I give you crystal, all of you can know crystal, metallic crystal like this. So here, so many kernels are formed. So many kernels are formed like this. So many kernels. In between so many kernels, there is a mobile electrons like this. They can attract each other. Okay. Like this. Okay, whatever the forces developing in between kernel and mobile electron, it is nothing but metallic bond. Entire this is called metallic cluster. Okay, this much of information is enough, students. So with this we completed what? Two types of bonding. In addition to ionic and covalent bond, we studied what is that coordinate covalent bond and also metallic bond. We have finished it. Let us stop here. Okay, the remaining part will continue in next class. Bye.